When producers start working with low and no alcohol products, one of the first surprises is this. Methods that work perfectly well at 5% alcohol suddenly become unreliable at 0.5% or below. Nothing has failed or stopped working, it's just you are now working much closer to the limits of what many methods were designed to measure. At typical beer strength, alcohol is relatively easy to measure. The signal is strong, the margin for error is wide, and small inaccuracies do not change the result in any meaningful way. Whether you're using distillation, density-based methods, or other traditional approaches, you are operating comfortably within the range of those methods and what they were built for. At 5% ABV, being a few hundredths out, that rarely matters. At low and no alcohol levels, that margin disappears. You are no longer working with a strong signal and plenty of tolerance. You're working close to the edge. A measurement that is off by just 0.05% might be insignificant at 5%, but at 0.5%, that represents a 10% error. And that is where problems start to appear. This is usually when producers begin to see results that feel inconsistent or are difficult to explain. Calibration ranges often do not extend far enough down to remain reliable. Baseline noise becomes a real factor rather than just background detail. Carryover and residual effects that were previously invisible start to matter. The method is being asked to operate outside the range it was designed for. Nothing has gone wrong, it's just the measurement challenge has simply changed. So what does work at these lower levels? Well, methods that separate and measure the ethanol directly tend to perform more reliably. Gas chromatography is one example. Rather than relying on bulk properties, it isolates and measures ethanol itself, even at very low concentrations. And because of that, it maintains resolution and accuracy where other methods begin to struggle. You are working with defined calibration ranges, clear separation, and sensitivity that is appropriate for low-level measurement. And that is why GC-based approaches are commonly used when producers need confident at or below 0.5% ABV. The important point is this. Low alcohol products are not just lower strength versions of full strength beer. From an analytical point of view, they represent a different measurement problem. If a method was built for 5%, it may simply not have the margin to work reliably at 0.5%. Recognizing that difference explains why some methods struggle at low alcohol levels.